Okay, so I gave you 5 sheets to put into your notes. In third period, I apologize. I think I gave you one out of order. So let's just go through the correct order right now. So we start with measurements of spread. There's 3 basic measurements of spread that IB cares about. First one is range, second one is interquartile range, and the third one is not MAD. IB doesn't care about that. We did that just to make sense of things. And the last one is standard deviation. Okay, so the order of the papers is going to be this paper is number 1, measurements of spread. So we talked about range, we talked about interquartile range, and we are going to do an example of those right here. This is page 2. So if I want the range is the maximum value minus the minimum value. So for this particular problem, the maximum value is 19, the minimum value is 7. I just subtract those, and I believe I get 12. The interquartile range is Q3 minus Q1. So here's Q3, here's Q1. So we're going to do 17 minus 8. So 17 minus 8 is 9. So for this, the interquartile range is 9. By the way, this box plot is the box plot for this dot plot. They actually represent the same data. Okay, and this set, notice here's the dot plot, here is the box plot. And I want you to notice something. Notice that the range on here is really big, just like the range on here is really big. But notice the box. See how this has a really big box, this has a really small box? Notice where the points are. Notice where the data is. The data here is out on the edges. And look how big the box is. Here, the data is grouped in the middle. We have stacks in the middle. And look how small the boxes are. So when you see a box plot that has a small box, it means that your data is not very spread out. And we should see that we have a very small IQR. So here we had a pretty big IQR. This one's going to have a very small IQR. And notice the data is not very spread out. It's all grouped towards the middle, towards the mean and the median. All right, so the range is going to be the maximum, 17 minus 7, so 10. This has a range of 10. And the IQR, here's the Q1, here's the Q3, so it's going to be 13 minus 11, which is 2. So if we're looking at the IQR, this data is much less spread out than this one. Their ranges are pretty similar, but their IQRs are very different because of the distribution of the data values. So, which data set has a higher IQR and therefore is more spread out from the center? That would be data set A. Is more spread out. It has a higher IQR. The IQR is bigger. Okay, so that's page 2. Page 3, mean absolute deviation. So we practiced doing this in class today. So it's really easy to do the MAD on a dot plot, but you can also do it from just a bunch of numbers. So in class, we practiced finding the MAD by just using our dot plot and just figuring out where the mean was and then counting the distance to the mean. But you can also do it just by crunching the numbers. Okay, so this is the 3rd page. You can do it by crunching the numbers. So here's the steps. So you have your data and you put it in order. So in this case, I had it on a dot plot. I took it off the dot plot and I wrote a list. So we're not going to do it on like we did in class. In class, we actually did it on the dot plot. But now we're going to do it by hand. So I want to find the mean of the data. That's step 2. So to calculate the mean, I would add up all the values and divide by how many values I have. So in this case, I have 10 values. I add them all together, divide by 10, and I got 4. So the mean is equal to 4. Another way of saying the mean is x with a bar over it. The mean is equal to 4. So if I was doing it on the dot plot, this is where the mean would be. So if we did it without the calculator and we actually moved the dots, we would have ended up here. Okay, now I want to calculate what is the average distance between each data point and the mean. So we're actually going to do that on this sheet right here. Okay, so we actually want to be able to see our data and this sheet at the same time. So I'm going to copy over all my data into the first column. So 0, 2, 3, 3, 4, 4, and 4 6s. And then I'm going to write down the mean. The mean is 4. And then I'm going to subtract them to see what the distance is from the mean to each of those data points. So x sub I, 0 minus 4, negative 4, 2 minus 4 is negative 2, 3 minus 4 is negative 1, etc. 4 minus 4, 0. All right, so now I found the distance from each point to the mean. We did this in class by actually counting the distance on here. We did, okay, this is 1, 1, 2, 1, 2, 3, 4, 1, 2, 1, 2, 1, 2. And we would have gotten these numbers right here. So then I said we don't care if it's to the left or the right, so we take the absolute value. So I take the absolute value of this answer. And now I'm going to find the average or the mean of these numbers. So I'm going to find the mean of my absolute deviations. So remember when we did this in class, we actually just wrote down all these distances and then we added them together and divided by how many numbers we had. So here we're kind of doing it a little fancier. We're doing it in a table, but these are the distances. So for example, from 0 to the mean is a distance of 4. So there it is. From 2, the distance from this dot to the mean is 2. The distance from point 3 to the mean is 1. And then there's another one from 3. That's the other one. Here's the ones that are on the mean, these 2 dots. And then these 4 dots are 2 units away. So now we have to find the average of this. We want to find the mean or the average of these numbers. So that's what this little symbol here is saying. It's saying sum, take the sum of the absolute value of x sub I minus the mean. Okay, so that's the data value minus the mean. So data value minus the mean, and I'm taking the absolute value, and I'm going to find the mean. So I'm going to add these all together, 4 plus 2 plus 1 plus 1 plus 0 plus 0 plus 2 plus 2 plus 2 plus 2. And then I'm going to divide by 10 because I have 10 pieces of data. So I'm going to add these together. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I'm going to divide by 10. And that is going to give me my mean absolute deviation of 1.6. So the average distance from each data point to the mean is 1.6 siblings. Okay, because these measurement is number of siblings. How many siblings? 1.6 is the average distance. So that, you know what? I don't know why I put siblings on there. That's kind of odd. But anyway, 1.6. Because this is discrete numbers. It's like, why would I have a decimal? But anyway, we won't worry about that right now. Okay, so our MAD mean absolute deviation is 1.6. All right, so that is page 4, and I think third period I told you this was the last page. I lied. This was part of the MAD. Standard deviation now is basically the MAD, but with a couple different steps. So this is the last paper, paper number 5, standard deviation. Notice if you compare these tables, they start doing the same thing. You write down all the data values, you write down the mean, and you subtract them. So same thing as here, you are taking the distance from the data value to the mean. So MAD, standard deviation and MAD start the exact same way. So I'm just going to go ahead and I'm going to copy this over because we're going to do the same calculation, but we're going to do a couple things different. 4, 4, 6, 6, 6, 6. The mean is still 4. It's the same data set. Now I'm just taking it a step further by doing the standard deviation. The next column, 0 minus 4 is equal to negative 4. Okay, I'm just going to go ahead and copy these over, but you would just be subtracting these. So this one's negative 2, negative 1, negative 1, 0, 0, 2, 2, 2, 2. Okay, now this is where things get different. On the MAD, we just take the absolute value of that. But if we're calculating standard deviation, we're actually going to square each of these. So we're going to square negative 4, and we get 16. We're going to square negative 2, we're going to get 4. Square negative 1, I get 1. Square each of these. Okay, so the two different steps for finding the standard deviation, then finding the MAD, is square the deviation rather than taking the absolute value, and then we're going to square root the mean of the squares of the deviation at the end. That's going to be the last thing we do. So, just like we did before, we're now going to add these all up. So we're going to have 16 plus 4 plus 1 plus 1 plus 0 plus 0 plus 4 plus 4 plus 4 plus 4. Obviously, there's a more efficient way of doing this, but I'm doing it the long way so you can actually see what I'm doing. So I'm adding these up, and then I'm going to divide by how many I have. So there's 10. And then the last thing I'm going to do is take the square root. I'm going to take the square root of that. That's going to be the last step. So that's what you see happening here. This is the notation for how do you find standard deviation. You take the sum of all the data points minus the mean squared. So that's this. You take all of these, you add them together, then you divide by how many data points you have. After you've done that, then you take the square root. The square root is the last thing that happens. Okay, so if I finish this off, 16 plus 4 is 20, 21, 22, 26, 30, 34, 38 over 10. So if I do that, that's equal to the square root of 3.8. And at this point, I need my calculator. So this is why we don't do standard deviation by hand, because chances are you are not going to be able to take the square root of at the last step. So here is my graphing calculator. I'm going to go ahead and do the square root of 3.8. Oops, there's something extra in there. Square root of 3.8. And I get 1.95 if I'm doing 3 significant figures, which is what we do in IB math. So 1.95 is my standard deviation. So notice when we did the mean absolute deviation, we got 1.6. When I do the standard deviation, I get 1.95. So sometimes these end up being a wee bit different. Okay, the MAD was 1.6, the standard deviation is 1.95. If you're interested in finding out why the standard deviation is what everybody uses instead of MAD for what everybody uses, you can go look it up because I don't know. Sorry about that. So here's our standard deviation. Again, only two things that we do different. Instead of taking the absolute value of the difference of the distance from the data point to the mean, we square it. Then we add them all together, divide by how many there are, and then the last final step is you take the square root. Okay, there's one other thing that you're going to be asked to find, and that's variance. Variance, we're just going to write this down, variance, and I hope I spelled that right. I'll fix that tomorrow if I didn't. Variance is equal to the standard deviation squared. Standard deviation squared. So basically, it's a way of finding the spread of data when you don't have access to a calculator, so you don't want to take a square root. Okay, so variance is equal to the standard deviation squared. So in this case, the variance would just be 3.8 because I don't take the square root. So variance is you stop before you take the square root. That's called the variance. And again, it's another measure of spread. You can use the variance to compare different data sets, but it's pretty much the standard deviation that has not been square rooted. That's the only difference between the two. So we will practice that the next time I see you. Bye-bye.